So we are interested in trying to figure out, is there a correlation between two things? And how strong is that correlation between the two things? So really kind of another kind of obvious example where there's a correlation is how old a fish is versus its length, right? For the first few months. Are you with me? Obviously, if a fish is born and then you wait a little while, it's going to get longer, right? It's what most fish do. Are you with me? Now, obviously, they don't continue that for their whole life, and you become the fish that ate in New York. But so that kind of thing, obviously, there's a correlation. Certain fish won't grow as quickly as other fish, but there is a general trend. There's also the trend, an imperfect trend would be how much you study versus your grade. Right? So why would that not be a perfect correlation? If you study more, why does that not guarantee that your grade will go up?
Intelligence level.
Yeah, maybe there's an intelligence level. I mean, it's a valid point. Also, does everybody study correctly?
No.
Right? No. You with me? All right. So there are, what we're getting into is analyzing one variable versus one other variable. There are more advanced techniques where you can analyze many variables at once and see who's got the most effect. That kind of makes more general sense. But this is a nice one to start with. This is kind of like exploratory statistics. If you see something that's really strongly correlated, then you go in there and you start doing more detailed analysis. Okay. Let me give you this here. Let's talk about this. You're like, do what you want to there, man. By the way, when I got the job here at Grossmont, I had to send in a video of a lecture I was doing. So this was the lecture I was doing, and it was all about the amount of beer you drink the night before an early morning test. One of my colleagues told me a couple years after that, I said, yeah, we kind of liked the fact that you were talking about beer. We thought you'd get along well with us. So I'm like, oh, okay, good. I'm glad I picked that lecture. Let's take a look here. All right, so I made up some stuff here, but this is based on experience. So the amount of beer you drink versus your grade on that early morning test, you would expect there to be some type of an effect, right? Now, now real quick, and which one of these is more realistic? Do you think that the beers you drink will have a direct effect on your grade for everybody? So if you drink one more beer, then your grade's going to drop by 5 points or something perfectly. No, of course not. So the first one is going to be more realistic. Let me see if I can play around. Is there a laser on here? That'd be awesome. No laser. Oh, there it is. Oh. So who is this person right there? That's an outlier. Who is that person? They drank...
Yeah.
Well, either they're a lightweight, right? So those beers affected them a lot. Or what's more likely probably is, no matter how much they drank, they ain't going to do well on that test. You with me? So maybe they didn't study or shit, or they didn't go to class, whatever the shit. So he made a very low grade, or she, but they didn't really drink much. Okay, versus this person, they drank the second most, but they still made a very high grade, so maybe they can hold their liquor or whatever, they just work through the hangover, or maybe they don't get a hangover. There are people like that in the world. Everybody with me? So those are outliers. Now how did I determine, if I take those out, even if I don't, you should be able to see this, but if I take those out, can you guys see where there would be what's called a best fit line? A line that I could draw that would average where all those points are. So let's try to draw that sucker, because you're going to have to do that later on your own. So if I cover those up, like an averaging line looks like maybe it would be roughly there. Well, I'll shoot my finger out of the way. Too bad. Right, maybe a little bit higher. So if ever I have to draw a line of best fit by hand, I do it with pencil first for the sure. Because the first time I draw it is probably not going to be perfect. I can erase it and then move it a little bit. Let me stop right there. Everybody understand the idea of that line? That line averages where all those points are. So this is kind of nice. It's like a two-dimensional average. And really, the heart of this line is it minimizes the distance from the line to every data point. That's the official thing for the best fit line. Very often it's called the least squares line, because it minimizes the square of the distance away from the line to all those data points. Okay, so it best fits the data. It's awesome. It's called a best fit line. It's insane. Now, obviously, the one for this one would be easier to draw, but it's also less realistic, right? Almost nothing lines up that beautifully, except for stuff like height of a person as they age. That's kind of like, of course, that's going to line up pretty well. Okay, how are you guys feeling so far? Which one of these would you say is a stronger correlation? Obviously. The first one or the second one is a stronger correlation? Second one. And so and why do you say the second one? Say again? More predictable. I like it. Why would you say it's more predictable, though? Yeah, the points are tighter to the line. So we want to eventually get to the point where we can calculate a number that will tell me the, kind of like the average distance away, but it's going to tell me how tight the points get to the line. Okay, so very kind of with. So it's sort of like a two-dimensional standard deviation, in a way. The numbers don't quite come out that way, but that's the idea of it. It's how tight do those points get to it? How far away are the data points from the average? Isn't that a standard deviation? I like it. In fact, I'm going to show you the formula once. We're actually not going to use the formula because I don't see the usefulness of it. I know you guys are used to me being always by hand. This is one section we're going to do pretty much all in the calculator. And then you have to interpret what the shit you get out of it. Right? Okay. I like this. Some of you guys went, uh-oh. Okay. So the second example. By the way, real quick, this is not a suggestion for an experiment, so don't. Just want to get that on video. Okay, so, yeah, my teacher said to drink a lot tonight. No, I didn't. And then here's the hours studied versus the grade on some test. Right? So again, which one is more realistic? Yeah. So this is one where this person studied a lot, but didn't make a very high grade. So either they don't know how to study, or just didn't really get through their head, something. And the person over there, the other outlier is somebody who barely studied at all, but they made a really high grade. And what I always say to people is, you don't know who around you has taken this already twice or something, so don't compare yourself to other people. Or maybe they took it in high school already, and they just have to take it again in college. You already know this shit, so do not compare yourself to other people. So again, this is a stronger relationship, but this is more realistic. I like it. So if I wanted to draw a line of best fit here, it might be something like that. My first approximation. This one's a little bit easier. Definite upward trend. I like it. So which one of these is negative correlation? First one, yeah, it's like a negative slope. And this is a positive slope, that's going to be a positive correlation. Which means as one thing increases, so does the other one. This is a negative correlation. As one thing increases, the other one decreases. I like it. So the number that we're going to calculate, or have the calculator do for us, it's given the symbol R, and it's called the Pearson Product or the correlation coefficient, depending on what book you're using. Pearson was somebody who did a lot of early stats work. Yeah, a lot of the stuff we use is based on his work. R goes between -1 and 1. That's the way the formula is kind of designed. So a -1, an R of -1, would be perfect negative correlation, meaning, get out of there. R equal -1 would be perfect negative. So all the data points lie directly on the line, and it's a negative slope. So R equal -0.9 would be strong negative correlation, but not every data point is right on the line. They're pulled away from it a little bit. As I pull them away from the line, -0.9, -0.8, -0.7. So what's R equal +1 mean? Perfect positive correlation. So it's going to be like that. So R equal 0.9 would be positive, but some of the points are a little bit off the line, and as I pull them away, 0.9, 0.8, 0.7. So what's R equal 0?
No correlation.
No linear correlation. Notice I'm being careful there. So no linear correlation could literally be this. Right? There's no line of best fit that I can see, really. If you put these in a calculator, it might say R equals 0.02 or something. Are you guys with? So the closer you are to R equals 0, the less evidence of correlation there is. Closer you are to R equals 1, that's evidence of positive correlation. -1 is evidence of negative correlation. One other way, yes, go ahead.
So those three numbers are your limits?
Well, -1 and 1 are the limits. That's the highest and lowest it could be. 0 means no correlation. -1 is perfect negative. +1 is perfect positive. So if I get 0.7, I'd say that's decently strong positive correlation. I like it. 0.1 would be like either really weak positive correlation or not enough evidence for correlation. We'll talk more about. I'm just going to give you the required number for showing evidence. Right? I'm not going to make you do a hypothesis test, if that's what it sounds like. You actually could, but I won't make you. And it kind of makes sense. The bigger your sample, the smaller your R could be and still be evidence for correlation. Because the bigger your sample, the more certain you are about what you see. Another way that there could be no correlation, there could be a line, but the line could be like this. Why is this no correlation? Well, this is sort of like how high I jump versus how tall that tree is. So, of course, there's no freaking correlation in how high I jump. Are you with me? So it could be a line like this or a line like this. That's a line, but it's still no correlation. As one variable changes, the other one doesn't give a shit. Like a tree, right? Now one day I'm going to do this, and the tree's actually going to grow. It's going to freak me the hell out. R equals 0 there, and R equals 0 there, and R equals 0 there. Because they don't care about each other. The variables don't give a shit about each other. You with me? I like it, maybe. Okay. So, let's do this. Anybody need a calculator? If you don't have one, you're going to need one. Make sure they turn on before you get too far away.
Did we do this in the 98?
Yes.
Okay. I've seen this before.
Thank you.
All right. Make sure they turn on. I managed to print this one thing out before my printer pretty much gave up for the day. I was going to give each of you one of these, but oh well. This is on that calculator guide that's up on the website. So I don't know if you remember, there's a calculator guide that tells you how to do a lot of things. Doesn't mean that some of you guys still, and I know the tutors might tell you this, but when you go see a tutor, you say, I've got insane Mr. Waller that won't let me just push buttons and get answers, so you have to explain to me how to do this. If they can't, it shouldn't be a stats tutor, period. So please, dear God, you should know by now that you can't just say, well, I used inverse norm to get, no, I don't care. No, don't show me that shit. All right. So here is how, this is the one section I'm going to let you guys just use the calculator. And let me real quick before I forget, I want to show you the formula. Just because there is one thing about it that is nice to look at. Got it. Got it. Ah, yes. All right. Okay. Load that boy up.
The calculator bags me away.
Thank you. All right. Some of you guys remember the formula for the variance was this here. There's another form of this if you kind of mess with this. Let me see if I remember it off the top of my head. All right. If you mess with this a little bit, you get this. And do you see how that, if I multiply down bottom of this by n, see how that's there? So there's a standard deviation basically for x's. There's a standard deviation for y's. So remember this r does act like a two-dimensional standard deviation in a lot of ways. It's supposed to tell me how far away from the line the data points get. It's kind of worked out so that if it comes out to be 1, that means they're just right on the line. So we kind of designed the formula so it would come out that way. But it's nice to see that there are elements of the standard deviation of both variables in the formula. That's the only thing I want to show you the formula for, right? Look at all the parts of this sucker. I mean, it's kind of, this is why I don't mind not making you do this. It's just an exercise in like busy work, where some of you guys think the rest of the classes, which you're wrong, but it's okay. But this, I agree with you. That would be just kind of busy work. So I want to do this. So take a minute, and here is an example for the beers versus grades. Can everybody see that okay? Can you guys see all those? Everybody? I'm going to take the silence as yes. Can you put the beers in list 1 and the grades in list 2 in your calculator? And I'll do the same thing. You doing all right? what I always do is, as I'm putting them in, I'm kind of make sure that when I'm like here, I make sure that I'm putting the right number that goes with 2.3. And this leads into my next question. Should I ever sort these lists? Hell no, because 3 has to go with 84, 4.5 has to go with 91. They are correlated. So I don't want to sort them separately, or else everything in the universe would be almost perfectly correlated. Okay. All right. So there's all the data in the first 2 lists. Now we're going to do this a few times because everything we're about to do, I'm going to need you to do on the test, on the final, and if we do a quiz on this, which we will do, and you have to bring it up to me at the table here and show it to me. So what we're going to do is we're going to recreate the data points on our screen, and then we're also going to find the line of best fit and have that sucker plot on top of those data points to see if it makes sense. Maybe. Okay, so here's how you get the data points plotted. You see right above y equals, where it says stat plot? That sounds encouraging. So let's everybody do second y equals to get the stat plot. And real quick, just everybody do this, just so I make sure that everybody starts in the same place. Everybody hit number 4. Number 4 just turns all the plots off, in case anybody has multiple plots turned on or whatever has happened with your calculator. You with me? Everybody see that? Number 4, you hit plots off, enter, done. So everybody done that, if you're playing along. Now go back in, second stat plot. Let's go into plot 1. So just hit enter for plot 1. Turn that bad boy on. I want a scatter plot, is what it's called. Scatter plot. I think we talked about those before. Scatter plot is just the XY plot. I think we did that back in chapter 2. Notice how it could also make histograms and box and whisker plots for you. My X list, it should default to list 1. That's where I put the X's, the number of beers drank. And then the Y list should say L2. So just double check and make sure that's what yours says. Then you get to pick. You get to pick if you're a square, if you're positive, if you're a big dot in the universe, or if you're a small speck in the universe. That's just going to be where it puts where the data points are. That's the symbol. I am obviously always a square. You guys can be whatever the hell you want to be. And on the newer calculator, you can pick the color that you want it to be in. So I'm going to do mine in, what do I want it in? Ooh, magenta. Get out of town. Let's do navy. All right. So everybody make sure it's turned on. You got the scatter plot showing, right? Picked the highlighted. All right. Now, if you just hit graph, it's going to be very unsatisfying. Just hit graph. Well, ooh, look at that. You guys can watch. Isn't that neat? Spirograph kind of shit. That's math 281, basically. Let me turn that dude off. I got some stuff in my y equals. Parametric equations, sorry. Make sure, hit y equals and make sure it's kind of cleared out. That should be a big step. Now yours probably doesn't look like this. Let me make your mind look the same way yours does. Make sure it's all cleared out. But still, when I hit graph, I'm not seeing my data points. Well, why not? Because the stupid graph normally defaults to negative 10 to 10, negative 10 to 10. And what were my grades? I didn't have anybody score a freaking 10. So everything's like happening up there somewhere. Is everybody with me? The highest grade here would be 10. Right? And nobody in that data set made a 10. I think I made a 10 in my class in a long time. Somebody got close. So what I always do, whenever you put new data in, and this is all on that sheet that I gave you, by the way, you hit zoom, and which one makes sense? No. Stat. I don't want to just zoom out. I want it to find my data points. the stupid calculator cost enough money. Calculator, find my data points. There. So you hit number 9. If you have the older one, you couldn't see it because it doesn't fit enough on the screen, but it should be number 9 for almost everybody. Just find Zoom stats. So let me know right now. Let me know right now if anybody is not able to get that showing up. Has everybody got that showing up? Oh, gotta turn that on. Go ahead. Turn it on. And select the scatter plot. Okay, now you should be good. Now hit Zoom.
Got it?
Number 9. It's not even showing up. Zoom 9, trust me. You can just hit the number 9 too. There you go. Turn it on. Hit enter. Now it's turning on.
I saw you like pressing.
Zoom. 9. Zoom stat.
I was just looking on this side.
It's Zoom.
This is like Zoom.
Number 9.
No, he's here. I wanted
What did I
to
say? Make sure your Y stuff is clear.
You were only.
Now go to Zoom. No.
Yes.
Zoom 9. So this, if you get an error that says dim mismatch, that's right. It's on right. That means dimension mismatch. It means your lists aren't the same size.
It's always weird when you're on my phone.
I'll just turn this off by 1. So yeah, it's trying to work off the data that you got. See how they mismatch? One is smaller than the other one? That's what dim mismatch means.
So you just need to make sure you know.
Yeah, so just put a number in there for right now.
No, I watched
Now
them
get
all.
Zoom.
You watched all of them?
That's what I told
It'll
you.
give you a
I've been
picture, but it's
watching
not the
all
same.
of them.
It's not the same.
I've been watching
Okay.
all of them.
Everybody else is good?
I was just like,
I always love technology day because so many things could happen. Okay, everybody else is good, I'm assuming. All right. So what's missing now is actually 2 things. This is pretty unsatisfactory because I could do this by hand pretty easily. Just plot the points. Ooh, thank you, $100 calculator. So what I want to do is force it to tell me what R is. And what's a good guess for R? Is it going to be positive or negative? Negative. There's definitely a trend down. It almost looks like it's 0 because of those 2 outliers. But if I took those 2 out, it would actually be a decently strong negative correlation. But since those outliers are there, I would guess it'd be kind of weak, like negative 0.4, negative 0.3. It's kind of a weak correlation because those 2 things definitely are not near the line. Are you guys seeing how things kind of work? The further I pull the data points away from the line, the closer R gets to 0. Because then it's not really following that line trend. The closer it follows the trend, the closer R is to 1 or negative 1. Based on if it's a positive slope or a negative slope. I love it. So here's how you do this. So again, the instructions are here on your calculator guide that you can print out from the website if you haven't done so already. Go to stat. Now I want to do some calculations with my data. So if I go to stat, calc, which one looks like it's going to tell me a line of best fit? There's actually 2 up there, but I don't know why they hardwired 2 in there. But which one has a line in it? Number 4, number 8. That's kind of stupid, right? Number 4, what's the slope? A. Remember good old mx plus b? So to be different, stat people had to say, no, it's ax plus b. So, anybody know why it's m, by the way? Mx plus b? Marche. It's a French word for to walk, right? So they use m for that, just to be different. And the stats people said we have to be even more different. So if I use number 4, and this actually stands for linear regression. So regression makes it sound like the hypnotherapy, but it's regressing towards the mean. It's a measure of how much it regresses towards the mean, towards the line. So linear regression. I want to do number 4. So we hit number 4. If you have the newer calculator, you'll see this. If you have the older calculator, it'll just say linreg. It defaults to L1, L2. I've got to go change this to L2. So make sure that's all that's in there. Do you see that? X list L1, Y list L2. There's no freak list. And hit calculate. Is everybody with me? Now if you have the older one, you just have linreg showing up. It defaults to L1 and L2, so you should just be able to hit enter. So let's see if everybody ends up at the same place here. All right. Anybody get an error? Let me clear those first. Oh.
It just gave me A and B.
Oh, I see. You guys had too much stuff going on.
I don't have no R. I have no R.
Now we'll talk about how to get the rest of that up there. Anybody else get an error?
No R.
Okay. That's the next question. Anybody have less information than me?
Yes.
Uh-huh. So let me show you. If you got your calculator right now, you only have to do this once. On the day of the test, if I give you a calculator, I'll make sure real quick that it's set up correctly. You with me? You only have to do this once, and I don't know why this is an option, to be really honest. All it does is it turns on more information to give you in a few different places. This is one where we need. So if you don't have R showing up, do this for me. You ready? Okay. Hit second 0. This is a catalog of everything the calculator can do.
Oh my God.
It's kind of insane. It's really long. Now I want to go to the D section of this. You guys see the D right there? You just have to push the button. It's already set up to be alpha. See the little A up there? You just hit this button. It should jump to the D's. Bam. Everybody with me? Day of week, yes. You put in there like a what was it, a month and a year. I'll tell you what day of the week it was. I can't remember the inputs.
That is so
I know, man. It's insane. So you know there's people that can do that too, right? Just human, their brains are hardwired for that. So no. Go to diagnostic on. Bless you. You guys see diagnostic on? Hit enter. Enter. And as always, it's pretty anticlimactic.
Okay.
Now, if you do stat, calc, linreg number 4, if you do that again, you should all get all this. All right, let me know if you need any help. Everybody good?
Yep.
Yeah.
Okay. So again, it's just doing that formula I showed you earlier. Okay. All right. So here we go. True to my nature, and this is the same thing. So you get to do it again. I do have a handout where you are going to do some stuff by hand, not the formula, but you will be drawing your own line of best fit, and you will be calculating the equation of the line of best fit using good old algebra. There's a reason it exists. So I pretty much just want you to follow what this says. I will give you a couple of pointers before you get started here. You guys can work together. That's fine. Now, if you do this correctly, everybody should get a slightly different answer. Possible. Possible if you get something in. So there's a couple things I want to make sure you understand going into this. First thing is, can I borrow a pencil from somebody? Thank you. So, everybody got one? Like I said earlier, if I have to do this by hand, I'm going to draw this line a couple times. And if I am you, I'm going to find a hard edge to help me. Right? Let's see if I can find one. Yay. Right. So I would take, and I would just kind of lightly do something as a first guess. And then I'll say, oh, shit. So what would you say? How does that have to be adjusted?
A little bit more down.
A little down. Okay, good. You get the idea. So then you would erase that, move it a little down. Do you guys see? So almost never will your first line be the one that you like. All right, so I would erase that. Make whatever sound effect you want. And then I would make it go down a little bit from where it just was. All right, so let's pretend like I'm happy with that. That's pretty close, I guess. Now, please, dear God, I'll make yours exactly the same as mine. Now, so find 2 points that the line goes through, not 2 blue dots, unless they go through them. So I'm going to pick, let's see, does it go through anything nice? Look, it goes right through this point. Do you see that? I'm going to pick that one because I can tell exactly what that point is. It's the point 4, 17. Do you understand? And then you find another point that it goes through. Let's see if mine goes through anything. You can even do, see if I can find like a halfway point. It looks like it kind of goes through here. 219. So yours, you might have a point up here and a point down there. If yours goes through a blue dot, that's great because it's a well-defined point. Does everybody understand what's happening? So I want you to try to get at least the A, B, C done. And look, I'm really nice. I told you the formula from algebra. Oh, shit. Oh, sorry. Oh, you're good? Okay.